So let's look at example number 1. We want to identify whether the following relationships have a direct variation, inverse variation, or neither. We're going to write function models for the direct and inverse variations. So as we see in this first table, x is definitely increasing. We got 2 to 4 to 10 to 15, and y is definitely decreasing, 15 to 7.5 to 3 to 2. So if we look here at our table, as x is increasing, if y is decreasing, we should be thinking to ourselves inverse variation. Inverse variation. However, we can't just say inverse variation, we can say possible inverse variation. In order to definitely 100% say that this is inverse variation, we have to prove it. That's rather simple to do. All we have to do is kind of utilize the equation that our table gave us. So inverse variation is y is equal to k divided by x. Y is equal to k divided by x. We can utilize that in order to help us to figure out whether or not this is actually inverse variation. So y is equal to k divided by x. Our goal is to make sure that k is the same for each value in our table. So I'm going to go ahead and solve for k by multiplying both sides by x. That gets rid of the x on the right-hand side, leaving us with x times y is equal to k. So what we want to do is make sure that each line of our table contains the same k value by multiplying our x and our y together. So we can say that 2 times 15 definitely equal to 30. 4 times 7.5 also equal to 30. 10 times 3 also equal to 30. And 15 times 2 also equal to 30. So if you notice, all of our k values would be the same. They're all 30. So this is definitely not possible inverse variation anymore. It's just inverse variation. We've proven that fact now. We can state that our function model for the direct and inverse variations, this being inverse variation, is going to be y is equal to 30 divided by x. We can state that because we actually solved for our k value whenever we did all of this testing and found that our k value was 30. So we can say that this is inverse variation and that our function model is y is equal to 30 divided by x. For the other example here, let's look at it real quick. X is increasing and y is again decreasing, so we can definitely say that this is possible inverse variation. And using the same idea as before, we can say that y is equal to k divided by x, multiply both sides by x to get rid of the x on that side, leaving us with x times y is equal to k, and we can use this equation to, again, check to see if this is actually inverse variation. So we can say 2 times 10 is equal to 20. 4 times 8 is equal to 32. So this is not identical. Notice we got 20 here and 32 here. Because those are different, we can say this is not varied. Okay. And we get to stop right there. Once we've proven that it's not direct variation or inverse variation, we can just say we're done. We can stop there. Actually, the better thing to write here is neither, because that's what the instructions say. So this is neither variation.